Hi everyone. So now I'd like to talk about electrons in atoms. So this is a PowerPoint that gives you more details about the electrons and how they behave in atoms, and more specifically how they are arranged or where you can find electrons around the nucleus of the atom. So first thing is, I wanted to go ahead and review Rutherford's atomic model. And just very quickly, I wanted to just go over the first part of this PowerPoint presentation and then spend more time, most of the time, just going into some of the details of the electron orbitals. So let's begin with Rutherford's atomic model here. You've seen this before, and you can see right here some of the basic parts of the model. The nucleus in the very center right here contains both the protons and the neutrons, and then surrounding the nucleus are the electrons. Here's another model, Bohr's atomic model, very similar in that the protons and neutrons are located in the center, in the nucleus, and the electrons are surrounding it. Now, both of these models, Rutherford's and Bohr's, can be considered hypotheses to help explain some of the things that scientists saw back in the early 1900s. However, as time went on, we saw that Rutherford and Bohr's atomic models were not very consistent with new theoretical calculations and experimental results. So what happened is that as better equipment came along and more experiments were run on those new pieces of equipment, it turned out that the information that those new experiments came up with did not really support Rutherford or Bohr's atomic models completely. So what that meant was we had to come up with a new atomic model. And here's a picture of Rutherford, here's a picture of Bohr, and Simon's saying thumbs down because unfortunately their atomic models were not correct anymore, or not exactly correct. So let's go to this gentleman right here. This gentleman's name is Erwin Schrödinger. And Schrödinger proposed a new model that's based on what's called quantum mechanics. And quantum mechanics is just a bunch of complex mathematical equations that will describe the behavior of electrons. Also describe some of the other parts of the atom, but more specifically we want to see how these electrons are behaving. Okay, Schrödinger's mathematical model involves the probability of finding an electron in a certain region around the nucleus. And probability, this is just a really fancy equation here, one of the equations that Schrödinger used. You don't need to know this, but the idea that I want you to know or to think about is that when we're thinking about the electron and where the electron is around the nucleus, it's just a probability or a chance of finding that electron around the nucleus. We don't know for sure where it exactly will be, but there's a very high chance or a very high probability of finding that electron. Okay, so an atomic orbital is this region of space or this area around the nucleus where there's a very high probability, and that's greater than 90%, of finding an electron. So that's the definition of the atomic orbital. Just think of it as a place where you're most likely to find an electron. Atomic orbitals are associated with different energy levels, and you'll see this in a little bit. And think of these atomic orbitals as these clouds surrounding the nucleus. We're talking 3 dimensions here, so that the clouds surround the nucleus of the atoms in 3-dimensional space. Okay, here's a picture of an atomic orbital probability cloud, and what we can see here is that where you've got all of these dots, right around here, that represents the high probability of finding an electron. And then our nucleus is right here in the very center, right here. Okay, that's our nucleus right there in the very middle. And so there's a very high probability of finding an electron out here. Out over here, say for example out here, there's a very low probability, or say a 0% chance, of finding an electron out here. But inside here, in this area right here, there's a very high probability or a very good chance of finding an electron. Okay, so this is the one I want to get into a little bit more detail here. Atomic orbital shapes. Okay, so atomic orbitals have certain shapes, and these shapes are a result of the probability clouds, or in other words, there's a high chance of finding an electron in these areas around the nucleus, and these areas have certain shapes associated with them. So there are really 4 types of atomic orbitals and 4 types of different shapes that I want you to be familiar with. The first is an s orbital, the second is a p orbital, the third is a d orbital, and the fourth is an f orbital. We are really going to focus in on just the first two. Okay, we are going to focus primarily on the p orbitals and the s orbitals. Okay, and then I'll give you some details on the d and some details on the f, but primarily just the s orbital and the p orbital. Okay, so the s orbital, it's shaped like a sphere, and if you're not familiar with the word sphere, just think of it as shaped like a ball. Okay, it's round and it's like a ball, or the shape of the Earth, for example. It's spherical that way. Okay, so just think of it as ball shaped. So we're talking 3 dimensions here. Okay, the next thing about an s orbital is that the nucleus is located at the very center of the sphere, or at the very center of that ball. That's where you're going to find the protons and